Uh, we got 10 of us here, so I guess we could get started. I see the Kingston crowd's not in tonight. Like I said, mentioned earlier, Michael won't be around tonight. He had a last minute, last minute brother showed up, so he had to go get him. So tonight we have Dave on tap with a talk on the PARC SNA, and speaking of the SNA, I've been using it a fair bit the last several days of the past week, doing crystal characterizations. But it's been, I think, one of the better projects that we've done in the PARC group. And I think the nice thing about this particular one is absolutely everything was done in house, from software to hardware, the whole kit and caboodle. So, and then after that, we can do a roundtable, and if anybody has any questions that they've got, then ask away. So, Dave, are you ready to go?
The crickets. Is that Eric? Can you guys hear me?
Yeah.
Yep. Is that Eric? He's playing the crickets.
Oh, maybe. Oh, maybe it's me with my clock. You seem to hear my clock.
You can hear the crickets. It's me. Well,
go staple yourself to the board.
It's whenever there's questions. That's what you'll hear.
Jeez, you're looking bright-eyed and bushy-tailed tonight. Like what's going on? Like
I had my Cheerios this morning.
Collect stuff.
It's just because I'm so happy to see all of you.
And he says that with his smile.
Oh, and I haven't had a drink yet.
Who'd we lose? Oh, Charlie.
Okay, so let me see what I'm doing here. Okay, can you guys see my screen?
No, just your face. Oh yeah, now's your screen.
Okay, so I'm using Google. On this computer I don't have PowerPoint. So I'm going to be using Google Slides here for this presentation. Can you guys see this okay?
Yes, we can.
Because there is a slide.
It's a little bit slow, but we can see it, Dave.
Because I could go into the slideshow mode, which makes it huge.
Yeah, we can see that as well.
That's good.
Okay, so let me try it this way and we'll see how it goes. So anyway, so in light of, when we were at Smith Falls and we were testing out the probe, the active probe, Peter was doing some sweeps with the spectrum analyzer, and we were getting some results, so we kind of scratching our heads. So we thought, hey, let's use a scalar network analyzer. That's the PARC SNA we built back in 2018. And we dusted it off, got it working, and it gave very similar results. And I was pretty impressed that it worked that well. So, Peter and I got talking, and we thought, well, maybe we should dust this thing off and talk about it a little bit more. So I said, I did this presentation back after we had built the SNA, and it was basically a presentation about how the SNA works. It's not meant to be a how-to video, how to use it, but it's basically explaining what the various pieces are doing. And just as a cautionary note, with all my presentation, I may not know what the hell I'm talking about. So take everything I say with a grain of salt. So what this is it's a how it works. So here's the PARC SNA completed with glass case, which, I'm impressed. We did a really good job with this. Frank, hats off. We did a fantastic job putting this together. It was a good teamwork, and we pulled it off, and it was a good piece of equipment. And so the PARC SNA, for those who don't have it or haven't used it, it generates a bunch of charts. And I'll go through what some of the charts are. The nice feature is that it can do overlays, where we could put multiple charts on one screen. It'll do 3 dB. It'll actually give you the 3 dB points of a filter, and you can see it here. I don't know if you can see start, stop, 3 dB 1, 3 dB 2. And here it's giving you the crystal motional parameters of a crystal. And so it's pretty useful, I think. So what this is not a user guide. I'm not gonna go through, how to program the Arduino Mega and the TFT display and how I2C works and how a thermonuclear bomb works. I'm not going through that. There is I did a bunch of YouTube videos. If this finally comes up here, it's taking its sweet time. So here it is here. So there is a playlist I've got. It's got a whole bunch of videos about how to. This is the how to. It shows you how to do a filter sweep, how to use the return loss bridge to do SWR, how to calibrate the device, how to calculate the crystal motional parameters, how to use the amplifier, how to sweep an amplifier. And it's got a unique feature where you could do almost everything from a CLI. And these two presentations, these two videos here explain how to use it and how to export data and et cetera, et cetera. So if you're looking how to use it, that's the place to go do it. Myself and Peter wrote the manuals for this. I can't remember. I think I did a bit of it, and then Peter did a bit of it, or Peter did most of it. But there are a set of comprehensive manuals we've got about the device. So that's where you should go if you want to learn how to use it. So from a high level, a conceptual design, this is basically how the SNA works. So we've got a signal generator. It generates a signal, and that's the signal. We know what the amplitude is, and I'm going to talk about that in a second. But we basically know what the amplitude and frequency of that signal going into a device under test is, DUT, device under test. And then we've got a signal coming out, and we've got a detector here that detects the signal coming out. And so based on that, we could sweep along a set of frequencies and plot what we see coming out. And from that, we can, look at filters and figure out SWR and all that good stuff. So that's conceptually how it works. So now I'm just going to talk about some of the use cases you could use it for. So first one, it's, as I said just now, you could use it for doing kind of a frequency dependent analysis. You look at how the output signal from your device under test, you're looking at this output signal here, how that behaves as a function of frequency. So some examples of how you could use this is a cable. You've got a 50 ohm cable, and is the cable good? Is it bad? Well, you could send a frequency down it, and you could see how it behaves at frequencies to see if maybe it doesn't work very well in the high bands and the high HF bands, or maybe it works better in the low HF bands. An amplifier. You could put an amplifier on this, and you could see, how it works, how it sweeps across the frequency. Low pass filter, is your antenna tuned properly, etc. So you could do a non-frequency dependent analysis because it does have a power detector, and that allows you to measure how strong the signal is. So you could feed in a VFO, a PLL signal, and you could see how strong that signal is coming out of a device. You can see how strong a signal is coming out of an amplifier, but you got to be careful. Here, danger, Will Robinson, is that you got to be careful with amplifiers because an amplifier could blow. It could have too much power for the detector, and you could blow it. And I said here, you could use this for SNR. I don't think you can, because after looking at the active probe and trying to figure out the signal to noise ratio, the noise floor for the active probe, I don't think you could do this, but it may be possible. Maybe someone smarter than me can figure it out. You also have a frequency generator. So you basically have a SIGGEN as part of this, and it's got a signal source that you could experiment with. It's a quick and dirty oscillator. You could use it to fix a mixer, to modulate it, to test a mixer, to do all kinds of different things. So let's now talk about the components. So let's talk about the generator part of it. So the frequency generator is based on the 809851 DDS, and that was a module that we could get from China back in the mid 2015s-ish. That was very popular as an oscillator, and the nice thing about it, it was putting out a sine wave, and it uses a 30 megahertz crystal with a multiplier, and it's basically advertised to go from 0 to 70 megahertz. But we found, somewhere around 30-ish megahertz, you start seeing harmonics, and the sine wave becomes less of a sine wave, so it's less clean. So the issues with this is that, number one, it's not 50 ohms output, and even worse, the impedance varies with frequency. So it's not a flat impedance right across the board. Even worse, the signal amplitude varies with frequency, not a lot, but it varies, by a few to several dB. And the signal quality deteriorates above 30-ish megahertz. So you get some harmonics coming out. And so the 9851 is connected to a microcontroller. In this case, we're using a Arduino Mega, and that selects what frequency that's coming out, that's being generated. So the way we attempted to fix some of these issues was that the microcontroller turns the DDS on, then the output from that goes into a 20 dB pad, and it's a 50 ohm pad, and then it goes through a 60 megahertz low pass filter just to clean up some of those harmonics we'd see around the 30 megahertz output frequency. So that will kind of clean up some of those nasties coming out. Then we added back a 20 dB LNA at the back, and I think, Peter, we used a MAR 6SM for that at the back end. So we have a 20 dB loss here, 20 dB gain. Net effect should be the same, ignoring any insertion loss from the filter here. And we got a fairly steady RF signal coming out. So now let's talk about the detector side of it. This is based on the 808307 chip, which many of you would remember from Wes Hayward. He published that article way back when, how to make a power meter using a 8307, and he had it connected to a meter. And there's been a lot of iterations of this over the years. But basically, it's a very sensitive logarithmic amplifier. It measures, output signals down to, it's advertised, down to about a minus 70, minus 80 dBm. And keep in mind, a strong RF signal is S9, which is minus 73 dBm. So this is putting out a fairly strong RF signal that your antenna would receive. So it puts out a DC voltage proportional to the power of the signal. So whatever signal it's got coming in, it's going to put out a DC signal, a DC voltage that the microcontroller is going to use its ADC to detect the voltage, and then that's going to tell it what the signal is. Now, it's very sensitive to noise. So you've got the power supply could generate some noise, and that'll impact the 8307. The RF signal itself could have noise that's coming in. The microcontroller has a clock, and it's, switching on and off and flipping bits, and that's generating noise on the PCB itself. And you've got the generator, which is also generating. It's an oscillator, so it's generating noise. So we have to figure out a way how to tame some of the noise here. So this is kind of what we did. Now this splitting up the regulator because the 8307 needs 5 volts to run, and I think this splitting this up was something that Kelly did, and I think he did it more for heat dissipation, because to go from a 13 volts to 5 volts, that poor 5-volt regulator is going to be dissipating a lot of heat. So by doing this, you've got 2 steps, and you dissipate less heat. So the 8-volt regulator is feeding, a 8-volt voltage to the microcontroller, and then the 5-volt regulator is feeding the 8307, and that is going through a LRC low-pass filter. So that's an inductor, resistor, and capacitor. So that's trying to tame any kind of noise that's coming in along the line that's going to the 8307 as well. The DC output from the 8307 is going through an RC low-pass filter to try and tame that. As well, we're doing some crude DSP processing in the microcontroller to try and tame some of that noise. And we also have a isolated ground plane that the 8307 is sitting on top. And this ground plane and the ground plane for the larger PCB is connected via one single 0-ohm resistor to try and minimize, multiple paths and ground loops and all that kind of stuff. So far, what we have is we've got a microcontroller configures the generator. It generates an output signal. It goes through the device under test. It comes out, the detector detects that, and it produces a DC voltage. So the problem here is that we have no idea what the output of this generator is. We don't know if it's 0 dBm, -3 dBm, +5 dBm, and I said that the output varies with frequency. So we have to figure out how we're going to know what's coming out of here, and I'll talk about that in a subsequent slide about calibration. And similarly here, we've got a DC voltage coming in. How the heck is this microcontroller going to know that 3 volts equates to, say, 0 dBm? So that's where we have to do some calibration. So I threw this slide in here just to talk about the return loss bridge. It's a device under test. It's a DUT here. The return loss bridge is connected here, and it has a signal coming in. It's got a signal coming out, and it's connected to an antenna. And the return loss bridge is used to generate return loss, SWR, and impedance. And the impedance is very low. It's 50 ohms plus or minus, say, 50 ohms. It's certainly not going to detect a 200 ohm or a 500 or a 1K ohm load. It's going to be something very close to 50 ohms. The way the return loss bridge works, I think you guys all know this. You've got a generator feeding in a signal to the return loss bridge. If no antenna is connected, the output port, all of what's going in comes back. You have a large reflection coming back. And in that case, you've got a low return loss. So the return, there's no loss. What's going in is coming back. So you've got a low return loss, and you've got a high insertion loss. So what's going through, you've got a lot of loss going through. So you've got a lot of insertion loss. And conversely, if you've got an antenna connected, it's perfectly matched, then what goes in comes out here. Everything is going into the antenna and very little signals being reflected. And in that case, you've got a high return loss. Everything that's being returned is being lost. And you've got a low insertion loss because everything is almost going through. There's no losses going through. Almost no losses. So the way I visualize this is using a dartboard. And so if there's no antenna connected, the target is really small. So if you look at these targets here, let's just say that's what you're shooting at the dartboard, you're going to miss the circle. You're going to be outside the circle and everything is going to bounce off. Whereas if it's perfectly matched, you have a really large circle, and anything you throw at the dartboard is making it through. This is something similar to something in nuclear physics called the nuclear cross-section. And you see that with certain particles have to have a certain speed, certain energy in order for it to interact with another particle. So that's kind of why I kind of visualize it this way. So putting this all together now, so we've got the programmable microcontroller, the Arduino Mega. It's connected to a display. It's got some memory, and this, you basically go on the front panel and you tell it sweep this frequency to this frequency, and blah blah blah. And so it goes out here and it generates a signal, puts it through the device under test. It comes out here, detector detects it, then it plots it on the screen. So that's basically how it works. And there's also a feature in it. It's got a CLI, command line interface, where anything you could do with the front panel, you could do with the CLI plus more. Plus you could also export the data to a connected PC for, like, if you want to put it into Excel. Okay, so I talked about some of the issues with how do we figure out, what 0 dBm is based on that voltage, and the signal coming out of the 9851. So let's talk about calibration now. So the first calibration is the 8307. So we need to calibrate that. So we need to be able to know what that DC voltage coming out is, how that equates to a dBm. So that's the first calibration we need to do. The next calibration is the 9851. That crystal is not perfect, because I said that it has a onboard 30 megahertz crystal. It's got a 6 times multiplier, then it divides it down and blah, blah, blah. But that 30 megahertz crystal could be 29.9998 megahertz, or some other frequency, and that could cause the output frequency to be different. So we need to correct that. So we need to know that if I tell this I'm putting out 10 megahertz, I'm putting out 10 megahertz. The next thing is that we need to know the signal strength of the 9851. And so we need to be able to calibrate that to know that if I put out a 5 megahertz signal, I know the signal coming out of the 9851 is going to be minus 10 dBm, or whatever. I need to know exactly what it is, because then what's coming out of my device under test, I could make a comparison. So the way we calibrate the 8307 is fairly simple. We have a signal generator here. I use the XG3, which is not, it's a terrible way to calibrate this, because the XG3 is not an accurate source. It's a good ballpark, but it's not an accurate source. You should use something that's got a fairly good, signal strength and frequency, and clean. And I think at the buildathon, we used some of Simon's equipment. He brought along some of his frequency standards, and we calibrated the SNA using his equipment. So this is very straightforward. So basically, when you go to calibrate the 8307, it asks you to enter 2 dBm levels you can be putting in, and it measures the voltage and it stores it in memory. Remember I said back here it's got memory, So it stores that in the memory. And what it does, it calculates slope, intercept, and it's able to figure that out. I'm not going to go through the math, but just know that after you do this, it can figure out what the dBm coming out of that 8307 is. To calibrate the 9851, the frequency accuracy, we need a signal, we need a counter, a fairly accurate counter that's able to measure the frequency that's coming out of the 9851. And so what we would do when we go to calibrate this, we select a frequency, say 10 megahertz, and we look at the frequency coming out here, and if this is 10.0001 megahertz, there's a knob we turn, and we adjust the compensation factor until this gets as close as possible to say 10 megahertz, or whatever frequency we set. And that compensation factor, it takes that and it stores that in memory, and it uses that from that point on to ensure that the frequency coming out is what you need it to say. So now the next thing is, how do we know what the amplitude, how strong that signal is coming out of the generator? Because I said that varies with frequency. So we do exactly the same thing we do with our spectrum analyzers, with the tracking generator. We connect the cable from the generator to the detector, from the tracking generator to the SA, and we do a sweep, and we normalize that. We know that, okay, this is what our tracking generator is putting out. And when we put a device under test, we could see how it performs relative to that. So same idea here. So basically what this is doing, when you go into the calibration of the output of the AD9851, it generates frequencies from 1 to 33 megahertz. And it goes, I think here it's going up in, 70 kilohertz steps. So it's going up, and it's measuring, it's putting out, say, 1 megahertz. It measures the signal voltage. Then it goes up to 1070 and so forth, and it goes all the way up to from 1 megahertz to 33 megahertz. I'm only showing here a small section. And based on that signal voltage from the prior calibration, it knows that 2 volts is, say, minus 9 dBm, and 2.01 is or 2.08 is 9.1, blah blah blah. It knows what that is. So, and it takes this table and it stores it in memory. So when we do a sweep and it wants to know what's coming out of here, it goes to this table and it says, oh, okay, at 1210 kilohertz, the output is minus 9.1 dBm. So that's what I know what's going out. Look at what's coming out from the device under test. Okay, so this is a really important point, and this could really mess you up here, is that, okay, the LCD I'm using, it's a TFT display. It's basically 480 dots across by 320 dots across. And I divided the display up into 4 areas. So at the top, there's a small banner, there's a plot area, and here is where you see all the data, and you start and stop frequencies and all that stuff, and then a banner at the bottom. So the plot area comes out to be 478 dots across by 220 vertical dots across. This 478 is important because when I do a sweep, I'm doing 478 measurements, period. I don't do 1,000 measurements. I don't do 200 measurements. I do 478 measurements always. So 1 dot represents 1 probe. And I do that for simplicity, for plotting, to make it faster and easier. The issue with doing this is your resolution. Okay, so for example here, let's look at a case where I'm going from 1 to 2 megahertz, or I'm going from, this could be 3 to 4 megahertz, or 5 to 6 megahertz, doesn't matter. It's got a 1 megahertz span between the start and stop. So because I'm doing 478 points, the resolution is 292 hertz, for example, for the 1 megahertz sweep. So what it means is that I make a measurement at 1 megahertz, then I set the controller sets a generator to go up by 292, 2.092 kilohertz, right? Goes up, then it makes a measurement, and it stores this in memory, and it does this 478 times. And you can see it here. Each time it's going up by 2092, which is the resolution. Okay, so it does this, and then it takes this and it plots it. That's what it plots. That's it. Bingo, right? The reason I'm bringing this up is this 478. If you do a sweep from 1 to 30 megahertz, that's a 30 megahertz span. So you take 30 megahertz, you divide it by 478 measurements, your resolution becomes really large. Well, large or small. The increment between your measurements is huge. So you could lose some information. So this is very, very important. So you got to choose your start and stop frequency appropriate for what you're measuring. Otherwise, this could lead you down the garden path. Okay, so that's basically the presentation. So I just got a couple of closing thoughts, a couple of things here, some things which will bite you in the ass, 100%. So first thing, it's how low can you go? Okay, the 8307, as I said, advertised you could go down to minus 80 dBm. I haven't seen an 8307 go down below, say, minus 55 dBm, just because of the noise, because that noise floor. And I said, you got RF noise, you got, noise on the from traces, you've got all kinds of parasitic noise, and that may cause the noise floor to go up. Now, this is very, very, very important. The 8307 is scalar. It's like it's open. It's very wide bandwidth. It's going from DC to over 1 gigahertz. So anything in that swath, anything that's coming in, it's going to take it and it's going to add it to the power. So in this case here, just say that's the signal we want to measure, and there's some harmonics or some junk. The 8307 is going to take the power here and add it to the power here and add it to the power here. And I think it does like a root mean square or something like that. It's not a linear where you take this, add it to that, add it to that. But it does mess it up. So that's why the 8307, we tried to clean it up as much as possible. Remember way back here, where was where's the diagram here? We put this low pass filter in because we're trying to restrict how much, junk we would get coming out beyond the 60 megahertz, because we found, around the 25, 30-ish megahertz, we started seeing harmonics coming out. Okay, so that's a gotcha right there. The next gotcha is calibration of the 8307. So because we're using a 2-point calibration, we could get some errors in the slope and intercept. So here I'm showing 3 different calibrations where the calibration values that we use, the 2 points we use, differed slightly a bit. And you could see it down around, what's this? This is around 3.5 volts. I think that's voltage here. So around there, it's pretty much the same. But as the voltage goes up, right, you see a bigger span here, and you see more error. So, and in this example, at about 10 dBm, the error is about 3 dB. And that shouldn't be dBm, it should be dB. And at 70 dBm, minus 70 dBm, we're getting, a 5 dBm difference out towards here. So it's huge. So, you have to try and get your calibration of your 8307 as accurate as possible, because otherwise your data could be off a bit. The other thing is scaling. Now, here's two different scalings. This is showing a scale here of 0.1 to 9.1 SWR, showing the same sweep. And we could see the two dips here, seeing a dip at about 20 megahertz. Here's about 40 megahertz. It's dipping down to 1.1. So we're seeing a SWR of around 1.1, about 20 megahertz and about 40 megahertz. And there's something here, but who knows what it is. But what I do in the algorithm I've implemented, I try and scale this to get the maximum resolution. And because I do that, you may see things like this. You may see dots, which is normal. It just, the resolution, the vertical resolution is so high, right? But pay attention. You may see these huge dips and go, "Oh my God, that's huge!" But it's still 1.1. It's about 1.1. But all of a sudden, you may start seeing some junk, which may not be present here. So you just got to be aware of that. That's just junk, right? So we may see some more jaggedness because of that scaling. For crystal 3dB sweeps, this is extremely important. Okay, the way I calculate the motional parameters is I take a look at what the maximum of the peak of the crystal is, and then from that I look at what the insertion loss is. I need the insertion loss. Then I roll that back to get to 3 dB to say, okay, from that point 3 dB down, what frequencies do I get? And I get my bandwidth. So the bandwidth, the center frequency, and your insertion loss, those are all important when calculating crystal motional parameters. So the reason this is important is if your crystal has any ripples, any ripple in it, okay, when I get the peak, am I going to use this peak? Am I going to use this peak, or am I going to use this peak? And is this peak maybe the 3 dB points here if you've got the ripple too big? So if you've got any kind of ripple with your crystal, this won't work. Okay, and same thing with your 3 dB sweeps. There is an option where it'll calculate your 3 dB points for a filter. For example, if your filter's got ripple, it may not work. Okay, and same thing goes if you got a flat top like this. How does it know where the center frequency is? I don't do any special curve fitting to say where the peak is. I'm just trying to wing it and figure it out the best I could. Because keep in mind, this is a bloody Arduino. This is not a PC. It's an Arduino. It's got limited horsepower, so, and it's got very limited floating points. So I have to work within that. Okay, so I call this the Peter perturbation. I have no idea why. I asked Peter, and Peter has no idea why. But basically, to measure crystal, you need to have a jig. And a crystal is somewhere around 12, ish ohms. The nominal impedance of a crystal is 12 ohms. So your SNA is feeding 50 ohms, 50 ohm signal, and it's got a 50 ohm detector here. So if we were to connect that to the crystal, it would load that crystal down, and the Q would suffer because of that. And so because of that, we put a 50 ohm pad here to force 50 ohms, take it down. And we've got a 2-to-1 transformer. So to take 50 ohms to 12.5, because I think 2-to-1, the turns ratios the impedance squared, or something, turns squared is impedance, or something like that. And same thing, you got the same transformer here to try and force this to be 50 ohms. Now, if you go to my crystal how-to video, you'll see in here, I talk about the jig. Where is it? Somewhere in here. Yeah, I talk about the jigs. The quality of the video is terrible. So I talk about the jigs, and and so forth. And one of the things I suggest doing is, instead of using the calibration for a straight through cable, you run a calibration using this with this shorted. You short the crystal, you put a short jumper across here, and you sweep it. So all of a sudden now all measurements are relative to any losses across here, right? And in this video later on, in the video, I don't know why I clicked that again to get it started again. It's really stupid. But if you go later on in the video, I do talk about that somewhere over here. Yeah, I talk somewhere in here. Anyway, you could go look it up and see what it's saying. So, and the other thing too to pay attention, I think this might be why I called it the Peter perturbation, is that if you look at, I wrote this program here to analyze crystal filters. Okay, so if you look, this here's a crystal filter, and these are the crystals that Peter measured. These are all the motional parameters he measured. And if we do a sweep of this, and you know, it's we assume it's terminated to 500 ohms, so you get ripple. You get the ripple in the passband here. The orange, this is actually doing a Gaussian curve fitting because it's a PC running this. But if we go and we optimize it, and it should be actually 310 ohms, the impedance, and we do a sweep, notice we get a much better behaved curve. We get less ripple in the passband here. So I think that's why I was referring to it as a Peter perturbation, because if you don't have this crystal terminated properly, you may get some ripple. I don't think so, because I think it'll just impact the Q. You'll get a wider bandwidth for the crystal, and that's it. So I'm just quickly showing the schematic. I'm not going to go through this, but here's the 8307. You could see it's on an isolated ground plane. There's a 0 ohm resistor connecting the two ground planes together, and everything that feeds into this section has a filter. This one has a LRC filter coming in, and this connection here has a RC filter. So we filter anything going into here to try and reduce the amount of noise that the 8307 would have. So that's it. So I'll stop this, and we can talk about questions or.
Okay, that's great, Dave. What a great review that was. I enjoyed that, and the crystal part there, you got me thinking. I just went through the whole exercise and finished off yesterday characterizing some crystals, and I soldered in what I thought was the best 4 out of the group. I remember calibrating the cables, but I can't remember if I inserted the crystal jig and shorted it out or not. Oh well, we'll worry about that for another day. Just a couple of comments before I turn it over to other questions. I believe, if I recall, Dave, you did the advanced programming guide, and I think I was the one that did the user guide. And what other notes? Oh, and yes, you're right about the MAR 6. We did use the MAR 6 on for the amplifier. And yeah, a lot of work went into that, and a lot of fun, a lot of learning came out of that. Especially, I never realized how sensitive cables were. When we were doing this project, there was probably, I think there was 3 of us. I think there was like myself, Frank, you, Dave, maybe even Ken, I think. I can't remember. Anyway, we were all getting different results, and we were all wondering what the heck is going on here, you know? And then we finally clued in that our cables were so sensitive. Sometimes just moving them around on the bench would alter the results. So we had to be careful on how we did that, and also use a decent cable. The other,
I was going to say, Peter, and it's pretty impressive that this piece of device that we built, you know, we put together ourselves, is that sensitive. that we could measure things to that level. And
Yeah.
it blows me away that how well this piece of equipment works.
It does. It works really well. It was an excellent project. And just as another aside here, Dave put an awful lot of work into that software. Just to give you an idea, there's about almost 7,000 lines of code in there with 26 unique files. So it was no small task, but again, it was a lot of fun, a lot of work. I have a couple other comments, but I'll save that for later. Ken,
and of course, sorry, let me just say, it's not all me. This was not all me, because I got a tremendous amount of input from Kevin. Without Kevin being a mentor to guide me in terms of how this thing works, there's no way I could have gotten this work. So Kevin played a vital role in helping me understand how this sucker works and how to develop the code.
Yeah, it was something. It was a good project for sure. Thanks for the clarification there, Dave. Ken, you have a question, comment?
Yeah, I do. I've got to say that we did a great job on this SNA. Took a long time to get it together, but it was a great job, and I'm using it once a month, twice a month, all depending. Actually, I was using it to peak QRP Labs filter, bandpass filter. The drawback is that the SNA is 50 ohm based. So if you use, say for example, you want to peak your DCR simple bandpass filter, the output is, I think it's 13 to 1500 ohms, whereas the SNA is 50 in. And on the positive side, though, you can use a toroid to step it down to 50. Yes, there will be losses due to the toroid, but you're measuring the output from the filter relative to the input. So basically what you're doing is you're peaking it to get your maximum signal. And that's what I did.
And that's correct, Ken. Like I wouldn't even put a transformer. I just connect it straight through. So what? It's the 50 ohm impedance is not going to impact the shape of your filter or the center frequency. It's not like it's loading. It could load the filter down, so you're going to see a higher insertion loss. But who cares? You're peaking it, as you said. You're just peaking it, and whatever that maximum is, you're going to tweak it until you get the maximum, and whatever that maximum is, it's tuned at that frequency, right? So I don't think it. I wouldn't have put a transformer on. I would just peak it. Now that's provided you're seeing something coming out, because it may be 1500 ohms to 50 ohms. It could be such a big voltage divider that you could see zilch coming out. It's just way below the noise floor of the 8307. Makes sense?
It does, and that's what I did, Dave. I just run straight through because I wasn't concerned with the actual numbers that were being shown. In this case, I was tweaking a filter, so I was going for peak, But yeah.
Yeah, for me, I happen to have a 31-6 toroid. So I just put it on. I use that. And I'm just peaking it, so it really doesn't matter. And I'm probably going to do the same thing with the QRP Labs filter, of which I was doing a quick check over the weekend. And my tests show that it could work with 1300 ohms. But I'm going to do a more detailed test on it, document it, video it, and everything. And that might happen this weekend.
Ken, actually, you saying that, what's one feature that we should have put into the SNA is a continuous sweep mode, where it'll just continually sweep. It just keeps going. It doesn't, because right now you got to sweep, look at it, do a sweep, look at it, do a sweep, look at it. Whereas if it's doing just continual sweeps, you could change it and look at it. You don't have to start and stop the sweep. So that, in hindsight, would have been a really good feature to add to the software.
Yeah, but we'll get by with the way it works. And what about the multi-sweep function? You can do what, up to three sweeps on top of each other?
More.
I can't remember how many files, but you could put, I don't know if it's 10 or something. You could put a large number of overlays. So you could go to your files and say plot these 5 files, and I'll plot them on the screen, and you could compare it. So like your sweep for your filter, you could save it and then plot it, and you could see what the trend is. But that's a fairly manual process.
Yeah, we did a great job on it. I'm very impressed with it, and I'm going to continue using it, even though I've got a Nano VNA.
Yeah, and you know what, Ken? Like as I said at Smith Falls, I had mine along. I haven't turned it on in years. Seriously, in years. I powered it on, connected it up, and it gave me numbers that were pretty darn close to our spectrum analyzer. I think, Peter, within like 1 or 2 dB.
Oh yeah, well within. Yeah. Well within that, you could trust the SNA.
Yeah, so I was blown away. I was absolutely blown away.
When you talk about the uses, Ken, and whatnot, and Dave, you were just saying you haven't used it in years. I understand why, because up until before I bought an SA, I was using the SNA a lot, for doing the filters and sweeps and the power meter, even and the crystal calibrations is particular. And then when I bought the SA, then the use for the SNA went down a bit, but I still use it mainly for crystal characterizations. And speaking of crystal characterizations, Dave, you're talking about the peaks that you could see and how the SNA will behave with it. I've done lots of characterizations between the LBS and the Phoenix and all that kind of stuff. And yesterday was day before yesterday was the first day I came across where one crystal showed a double peak in it. Other than that, I've always been able to see just the one peak, so I guess I was lucky. But anyway, what else have I got down here?
That could be, Peter, that could be some kind of parasitic oscillation you're seeing, because a crystal should theoretically have one peak. Now, it could have a peak. Some, like the crystal should have I can't remember, it's a series resonance and then a parallel and then a big dip.
Oh, yeah, then it comes back.
Resonance, I don't know. Hassan might be able
to comment. One's a
comment.
series and one's a parallel. You're right, Dave. That's why you get that double peak.
Series, one's parallel. So you might see that, but it's a peak and a negative peak. It shouldn't be like 2 peaks, a ripple. So if you're seeing ripple, I don't know. My guess would be you're seeing some kind of parasitic oscillation.
I'll have to take another look at it. I think I marked down which crystal it was. But anyway, one other point I got here, and somebody else has questions or comments, put your hand up. I'm curious, out of the group here tonight, maybe when we do the roundtable, just maybe make a comment whether you built the SNA or not. Okay. Anybody else got some comments for Dave? Questions? Okay. Oh, Frank. Yeah, the father of all this stuff.
Yeah. I just want to comment to Dave. That was a good presentation. And I went back a few years and had a few good memories as you went through of some of the situations we had with it, some of the problems and some of the successes. But all in all, that was an excellent group project, and I think the our club should be really proud of what we produce. And so thanks for the memory there, Dave.
And I think, Frank, I could even add to that and say at the buildathon, I think there were no seats available. I think that buildathon, because it was in the basement of the church, and I think there were no seats there. I think every seat had a bum in it. We built a number. I can't remember. Does anyone know?
I'll bet you it was around 30 or close.
Yeah, and it wasn't cheap. It was over. I think it was over $100.
75, I think, maybe 80.
Yeah, it was around $100. So it was certainly one of our more expensive builds.
You know, when we got some parts from Q-Kits, the local supplier here. I forget which parts it was we were after. And I got to talking to this guy, and he said, you know, what are you guys doing? And so I told him what we were doing, and he says, well, you know what? He says, if you want, I'll kit it and I'll sell it. You know, he says, you don't have to do anything. But you know what? It wasn't I think within about a year, the tiny SAs and tiny V&A started to come out, and wouldn't have been cost effective by then.
By the way, have you guys seen that Alan Wolke video on the big brother to the Nano VNA?
Yep.
There's one,
new one, but that's not a cheap item. I think that's like $700.
Is it? I thought he said it was a few $100s. I thought it was. He said it was a little bit more, but was it? Is it really $700?
I think so.
That order?
I can't remember if that's Canadian or US, but either way, it made the decision easy.
See, I was hoping it would do. I think it's an S22 measurement, where what's like to measure the output impedance. It measures the input impedance of the device, but it'd be really nice to measure the output impedance of a device.
Yeah.
You know, like an amplifier, like remember for a probe, we were trying to figure out how to figure out what the output impedance is.
Yeah.
And if we had a real VNA, it could measure that.
Yeah. Cherry's asking for the link. Just go to Al Wilkie's YouTube channel and you'll see it. It's one of the last ones he did, I think.
Yeah, I think it's his most recent.
Yeah. You won't have to go very far to look for it.
I see Cherry's eyes are glint. He's looking to buy something.
Yeah, buy that device, Cherry, and then you can deliver to each one of us when we need it. Yeah, that'd be good.
Cherry's glowing. He can go buy something.
Buy. Okay. Does anybody else have any comments?
What was that guy's name?
Al Wolke.
W2AEW. Just
okay.
Google it. Go on YouTube and just say W2AEW.
Oh, I know
see
that. Also, I never knew the guy's name actually. Yeah.
Yeah, it's Alan Wolke, I think, right?
Yeah.
Did I say
that
right?
Yep. Okay. All right. Well, thanks very much for that, Dave. Very good. Like Frank said, some memories. Okay, we got time for some roundtables here. One thing to remember is we'll be back into our regularly scheduled program starting this month. So we will have a main meeting in a couple of weeks and throughout to the winter. What else we got going? Well, I guess I'll start with myself. On the bench, I've been doing a lot of crystal characterizations and doing another receiver for the backplane board. I had to use my troubleshooting skills. I thought, I guess I got a little bit careless, and I didn't let the smoke out, but I think I was close because the LT1253, of course, it would be that chip, the expensive chip, and not the cheap 612 chip. It was getting a bit hot, and I ended up finding, because I was modifying an existing circuit, I left out a capacitor, so that didn't help. So that was what was causing a bit of a short, and I had a bad solder joint, so that didn't help things either. So I fixed that all up this afternoon. And I thought, well, I'm going to quit while I'm ahead. I'll put the RF to it tomorrow. I thought I'll dine out on success today. And other than that, that's pretty much all I've been doing in the shop or in the shack. And I guess with that, we'll go on to next on my screen here. Or I guess, hey, Al, you're next on my screen, but we already touched base there. I mean, you got any plans in the shack going forward in the near future? New year? No, you're still muted. There you go.
Who, me? Oh, okay. Nothing planned right yet. I'm still rebuilding my basement and my shack, so
That's
the
the
only
priority.
radio I'm playing right now is in my mobile, but that's soon to have that fixed. With regard to the SNA, I built it. I love it. I still use it, even though I have the spectrum analyzer and the VNA as well. But it's a remarkable thing, and yeah, congratulations to everybody that put that together. I think it's a keeper.
Good. All right, thanks, Al. Bob, how's things in Georgia?
Well, I'm just, I've been relocating for the last like 6 months, and I finally settled on a place, and I'm sharing it with my daughter, and I've got the shack halfway done. All of my building and testing equipment is still in storage. Hopefully I'll get it out next month, and then maybe I can start to burn something. But I've not been experimenting, building, or on the radio for about 6 months now.
Well, we won't complain about that, Bob. But if you're still like this in January, we might have to take issue.
Okay, you guys take care and be good up there.
Yeah, Bob.
Yeah.
Yeah, and Bob, if any of those 3D printers you've got need a home, let me know.
Oh, I gave both of them away.
You did? Oh man.
I gave both of them away. It takes up too much time. It takes up too much radio time. It's a very time consuming hobby.
Yeah, because I remember seeing them in the background. You had some pretty good units.
Yeah, I had a Prusa, and I had another one of which I can't think of the name of, but they worked okay. They worked okay when they did, but the problem with 3D printers, as we all know, is that you got something that's going to take 6 hours to print. You go upstairs, you take a nap, and you come downstairs and you find out, that nothing worked, and you got all this filament all over the top of the platform, and nothing printed. So you got to. What I'm going to do is, I think when I do it again, I have a camera, and I'm going to put a camera there, so when I wake up in the middle of the night, I can look at the camera and see what's happened.
Yeah, I call that, Bob, printing a cat.
Yeah, yes.
It's like a big fur ball you printed, and it's just all filament, right? And it looks like
I wish I could sell those. I could make a lot of money. I think it's something I'm going to tell people I built it on purpose.
Very good, Bob.
Okay. Eric picked up your 3D printers, right?
Eric picks up anything. Okay, Dave, you're next on my screen.
Yes, I've been doing a lot this summer. I've been trying to emulate Kevin and do as much camping as I can. But besides that, I took my antenna down the other day. Remember, Al, you were helping me look at some of the loads on that mast, my aluminum mast. So after, what was it, 2 years, 3 years, I took it down. I thought, let me take it down, inspect it. And I took it down. I'm glad I did, because you could see that it was starting to separate a little bit. And I took it, so I used some new mast, put it up, and I got it back up, and it's working. But one of the things I want to do is I want to shorten my cables, because I was lazy, and I didn't want to cut some of my cables. So I've got just coils and coils of excess cable. And I thought I'll just wrap it together and make a I think it's called ugly balun. But you know what? That just cuts down in power. And I've got just too much cable. So my next thing is I'm going to have to start cutting my cable.
A much larger soldering iron than you've been using lately.
Yeah. So that, and besides that, I've just been working on building and flying rockets, but that's it.
Okay, thanks, Dave. Do I dare ask Eric what he's been up to? He's not even there. Okay, we'll skip over. Frank. Oh, wait. Okay.
Well, question for you. I'll go right back to you. What year?
What year? What?
Is my audio not good?
Well, it is now.
Okay, let me just kick up my performance settings. Is that better?
Yeah, try it. What'd you ask?
Hello? Yeah, my question is, what year was the SNA Buildathon?
2018.
2018.
April, I think.
2018. Okay. All right. Have I used it? Of course not. But
did you build it?
That was a good overview, actually. I appreciate I built it, but I just have not put used to it. But I did learn a few things in this go over presentation. So I appreciate that, Dave. As far as what I'm doing, radio related, not very much at this point, unfortunately. But with the very tempted to get an antenna, so at least I have something for the winter months to play with. Seeing that looks like we're not moving this year, so get my vertical back up. So,
I thought I had.
Right,
I thought you were going to say you're going to start emptying out the trailer.
Emptying out the trailer. My library, never. Anyway, so all good.
Yeah, your audio's chopping there.
All right.
Eric.
So that's pretty much all. Is it really? Okay. Okay. All right.
Yeah, you're gonna have to fix
maybe
your
not the
audio,
best
whatever's
connection
going on.
here, but anyway, all good.
I'll text you later.
Okay.
So, based on what Eric was saying, does anybody here want to buy a Virgin SNA? Just let us know. Frank, what have you been up to? You got to unmute yourself, though. You have to unmute yourself, Frank.
What happened?
Oh, you didn't unmute yourself.
Yeah. All right. That's better.
Yeah.
Yeah. What I've been doing all summer is playing around with this idea that I wanted to build a analog frequency dial that looks something like an old 50s or 60s radio, but do it digitally. And I started out with a picture from the solder smoke that they didn't get into much of what was behind it, but it was just a picture. And I said, hey, that's good. I want to do that and put it on the DC receiver we built. So remember last time we were together, I couldn't get the microcontroller hooked up to the screen and everything, but all of that is fixed. And there's a large learning curve that I went through. And with the help of AI, I'm making slow progress and learning a hell of a lot. So it's been a fun thing. There's no pressure with it whatsoever. So that's what I'm tinkering with. So it's mostly down to software now and fiddling around with that. So that's about what I've been doing. I haven't been on the air at all. So it's mostly been playing around on the bench. That's pretty well sums it up. Back to you, Peter.
Okay, thanks, Frank. It'll be most interesting to see in the end results when you're ready to show us what you've done there.
I will. I'll be very proud of it if I get it working like the picture.
Okay, thanks, Frank. Let's see, Cherry.
Okay. So I have a few things. Like, first of all, I wanted to just mention about the PARC SNA. Yeah, I think that was a great kit that we, I still remember the buildathon. In fact, it was my first buildathon after joining the club, and it immensely impressed me. This a lot of people like Dave, Peter, Frank, Kevin, Ken, everyone. I think Eric also I met, everyone in this group at that time. And I was heavily impressed because the kit was great. And I had a great time building it. And this group was a keeper after that. So that was really great. I still have it. I don't use it very much, I have to admit, because of shortage of time and other things. I don't use it very much, but I still treasure it. I kept it at a place where it doesn't gather dust. And then I really plan to use it in the future. And I want to compare it with some of the nano aerosols and so on. So for crystal measurement or crystal related activity when I'm doing it, I talking about crystals, I got some crystals recently to do some crystal filters and so on. I have some plans. But yeah, this was really awesome. I think that was not a small job. Having the kit, all the components, sourcing all the parts. I think a lot of people had spent immense amount of time developing this kit as well as sourcing the kit, and even organizing that place. I still remember yesterday, we had many members who participated there. In fact, the table was full. And I think followed by that kit, we did the PARC SNA. That was also, that did also went very well. And I think there were even people helped calibrating and calibration and so on. So this was really great. And I narrated it to my friend, in Germany, and he was even immensely impressed by the activities which we have done that day. So I think I have a lot of words for this kit buildathon. And what am I doing? What is on my table? Yeah, I have some crystals which I'm planning to play with. And also my major activity in my shack right now is to organize my shack, because it has it has slowly I'm buying some stuff from the Hamfest, and it is piling up in terms of books and so on. I have can you still hear me? Yeah, so it is becoming a lot in my room, so I have to really organize it and make sure that I can build some things efficiently, because a lot of things are some things I'm really finding it very difficult to find and have continuity on a project. So that is something which I just wanted to mention. Otherwise, I'm doing great with all these hampers and everything. 98% of the time, the time I spend on ham radio is, I think, 99% is on ham radio, 1% is on homebrew. That's my status right now. Yeah. Okay. Thank you. Thanks.
Okay. Thanks, Jerry, for that. Ken, you're up next.
Yeah, I was part of the SNA team. I think most of my time was trying to get parts, and that took weeks. You couldn't just get them at one place. You had to go I think 4 or 5 different suppliers to get it. The LCD was available at that kit place in Kingston, but they only had so many in stock, and so I had to back order and wait for that to come in. And but you know what? It was well worth it. I don't know if we would be able to get the same parts if somebody decided they wanted to build it.
You know,
We'd have to look for it.
it'd be too expensive to build. You know, you'd be into the $100 range.
Yeah.
You know, so what's a V&A cost today?
I don't know.
Well,
wasn't that SNA over $100? I think it was
I
100.
thought it was just under, but it could have been just over. It's in that area, so you know you're into the, you know, you're not that far off of an SNA, right?
Yeah. You know what? It was fun. It was that was probably the most complex kit to work on since I got back into ham radio and I joined the Peel group. You know, back in the days, I wanted to build something. You had to mail order everything.
Don't forget too, when we designed and talked about that SNA and building that, there was nothing in the market out there like it. And you know, if you wanted to buy an SNA, it cost you a hell of a lot more than what we put one together for.
Yeah,
there's just nothing out there. It was on its own. That's why the guy at Q-Kits took an interest in it.
Yeah.
But then, like I said, what, a year later, the tiny SA came out, or tiny V&A came out.
Yeah.
Anyway.
Exactly. But anyways, besides that, I've been looking at a way of modifying the QRP Labs output to work with the DCR. I think I have a way figured out without having to do any major modification to the board. Maybe this coming weekend or the weekend after, I'll do a modification, document everything, video everything, and according to what I worked out by numbers, it looks like instead of taking the output from the output of the toroid, he's taken off the top of the input of the output toroid. And at the different frequencies, this comes very close to the input of the chip, which is close enough. But
okay, we'll report on the 17th then.
Sure, okay. Which month?
This month.
What do you mean this month? Maybe. We'll see. I got time. Other than that, I'm sort of getting ready to put up my random wire antenna. My old end fed's coming down, and give that a whirl and see how it goes. Other than that, that's it.
Okay. Aim for October 1st.
Okay.
Thanks, Ken. Okay, Kevin, you're up next. Did you get any poison ivy? Learn some new songs? I know all you've been doing is camping and going to music festivals this summer. I see you're growing your hair longer too. You're muted.
Right. Whoops. It fits with my new hippie theme. Birkenstocks, long hair, and a guitar.
Yeah.
Actually, just want to. I know that we thought that this was the first one, but I'm just going to remind. And I have one of these. This was out in 2016, the Midnight SNA.
Yeah.
And it has a lot of, I think everything that ours does almost. And to be honest, I think the software in ours is a little more user friendly. Yes. Oh, you have one too. That's right. But it has an SD card to store stuff, which is kind of interesting. But yeah, you look at the menus and the screens. I don't think it's as easy to use. But anyway, it was out there, and I had a problem with the screen too. It failed, and anyway, he replaced it, and because this was the George Heron one, right?
Yes.
But anyway, just
I had problems with mine as well, Kevin. I can't remember what the problem was. If you look at it now, it's full of dust. And I started to try and fix it, and I think I ended up giving up. And then we were doing our own SNA, and I never looked at that thing. I should look and see what I could rob out of it, or maybe fix it and sell it to somebody. Anyway.
Well, I mean, I've used it as like a power meter, a couple things, some things like that, like because it does have an 8307 in it. And the other thing that I was looking through some of my notes from then, and it's like, even that shield that we put around the 8307, that got rid of 5 dB of background noise. We went from minus 70 with no connection, just sitting there. Went from minus 71 to minus 76 just by adding the shield around the chip.
Yeah.
That little brass shield is like, just little things like that made a difference, right?
Well, I'm trying to remember. The 8307 had, I recall, 2 lines, like one that was pretty linear from down to about minus 70, minus 65, something like that. And then it healed over a little bit, but then the next 10 dB or so was quite linear. 15 was quite linear. But then after that, you're down pretty low. And to Dave's point, you're so low that you're into the mud, I think, with the noise.
Yeah, I think then there's all kinds of, who knows what's coming from where on the board and stuff. But yeah, and I have a whole bunch of notes just on things I was going to do with it, and like just like, oh, where is it? Oh, like even on here, it's like, oh, that's it. I was going to use it, for testing coax stubs. You can do a field strength meter if you put a little bandpass filter in there. Anyway, just, I had all kinds of stuff that I was going to do. Meanwhile, I haven't been doing much of anything. And I was just looking at my project's to-do list. And it's like, and I was kind of like sorting it and prioritizing it. I have 16 items on there, and some of those are multiple steps, like multiple things in a given project. And it's like, oh my gosh. And the backplane radio is only one of them, but it's like I'm never going to get done. I should have retired 20 years ago to get this.
Well, we tried to tell you that.
It's like, anyway, but yeah, I'm getting back into it. I actually spent the day organizing my shack and my bench a little bit because it was a mess after not giving it any attention over the last few months. But summer's pretty much over, so other than our camping trip next week, Dave, it's like it's gonna be.
Does that mean you can't make the backplane meeting next week?
Oh, is that next week? What night is it? Thursday? Oh crap! I should have checked. Well, if we have cell service, I can still do it.
Yeah. Here, I'll get the calendar.
Kevin, there is at the campsite we're at. What kind of phone do you have? Do you have an Apple or do you have a Android?
No, Android.
Android, because Apple, I find at that site, you get a little bit better performance. So, worst comes to worst, if you want, we're not far. We could paddle into Whitney or something like that.
Yeah, but it'll be dark.
True. Yeah. Yeah.
Hey, just try.
I don't want to paddle in the dark. I don't know about you, but.
Just try it, Kevin. The meeting is on the 9th. So
yeah.
So just try it. If you get in, you get in. If you don't, you don't. Or you know what? Try the day before or something like that.
Yeah, no, I will. Yeah.
And then if it gets in, give me a shout. And if not, then just send me a bullet point of what you want to say.
Yeah, because I can just do audio, right? So.
Yeah. Okay.
Anyway, but yeah, so just getting back into it and finishing my KiCad lessons and
that's right,
to the backplane stuff.
What lesson number are you up to?
It's the same as it was back in June, whatever that number is. Okay. I really have not.
I think Michael is approaching 100. I think, or
yeah, I'm around 100 or just under 100. I think, but
yeah, I've only done a couple of lessons over the summer myself. So anyway.
I find you have to do it, in a bunch. If you do them once every week or something, I lose my place. So, but anyway,
Okay, good. Excuse me. Thanks, Kevin. And Hassan, up to you now. Anything exciting on your bench?
Um, yeah, let's see. Work, work, work. I've been busy.
That's not on your bench.
That's not on my bench. But, um, yeah, the summer's been super busy, but things are finally stable. We've got our design. I mean, we finished our design, so now it's implementation. But I'm I'm hiring some people, and one of them actually worked on a voice-controlled interface for something using AI for a web browser. So I interviewed the guy, so maybe get some tips on how to actually implement that in some of our projects too, because it's getting easier and easier. Apart from that, no, I was thinking about the history of the SNA. Um, I remember, I think I showed this thing called the octopus curve tracer. Do you guys remember that thing? This
Yeah.
something with with three parts you can build a curve tracer and a scope. And I think after that, I remember you guys sort of like there's a whole bunch of discussion about how to do an SNA or the proper way to do a curve tracer. And then I think that's when you guys took off with that idea of the PARC SNA, and it was an amazing buildathon. It was actually, I was, I too was impressed with the level of like the educational content, the level of rigor and explanation was amazing. Like it was my first buildathon too, and mine didn't work the first time, but I brought a thermal camera in, and I remember hooking it up and seeing that one chip was way hotter than I compared it to somebody else's board, and one of my chips was really hot. I think it was the log amp or something. And so then I just desoldered it, put a new one on, and it worked. So that was kind of an interesting thing. Um, yeah, I guess. And while you guys were talking, I was trying to think: is there a way to make this thing contactless, so you don't have to have coax cables coming out, and your DUT doesn't have to be your device under test doesn't have to be 50 ohms in and out. You can just put a probe down on a PCB trace and just measure something in circuit. That would be really cool, but that'd be really tricky as well.
Like anything.
Yeah, although that could work well with a backplane project as well, because if you can inject a known stimulus current or known voltage in any part of the circuit, you could calibrate your thing on the fly. You put a non-contact probe on there, basically a tiny coil, stick it on top of a PCB trace, and then you put like 1 amp through it, measure it, and now you've got a calibrated reading, and then you put it past the current through your device, your circuit, and you can do a proper reading. So with that might become possible with the backplane project. So let's see.
Okay, interesting. Okay, thanks, Hassan. See, we're at about 9 o'clock now. So, Dave, you got a comment?
Yeah, just a final comment here. I could do a couple of presentations, short presentation. I don't know what the appetite is for the group, but I just thought I'd just mention it, see if anyone's okay with it. This summer I was up in North Bay, and there's a really cool museum there, the NORAD museum up at the old Air Force Base. There's pretty much shut down now at the airport, and they've got a huge NORAD installation below there. And I took a whole bunch of pictures and talked about over the horizon radar. So I could put like just a photo essay about that museum and just talk a little bit about, because I looked into what over the horizon radar looks like, and with the the U.S. saying that they're doing that golden dome or whatever, and it's they could do it without Canada. That's not true. So it has to have Canada. But anyway, that's one. So I could do that. The other one is I again another short photo essay, more photographs of my build, because I photographed the build I did of a rocket, so I could go through all the things I did to build one of my rockets. I don't know if you guys would be interested in seeing that.
Oh yeah, I think so, Dave. I know I would be. And I was just looking at our schedule. Both, let's see, the regular meeting on November 19th is available. The mixer on December 3rd is available. If you're interested in taking those spots.
Yeah, and again, Peter, these are going to be short, like 15 minutes kind of thing. They're going to be short, little presentation, because there's not much. The rocket one might be a little bit longer, might be 20-ish minutes, but it's just a bunch of pictures I'm showing, and I'm describing the pictures, right? Same thing with NORAD. I'm not going into a lot of detail. I'm just showing what was there and what the installation looks like, and just talk about what over the horizon radar is, and that's it, you know.
Another spot, Dave, for the mixer could be November 5th. We can talk later, and we'll figure something out.
Yeah, October I'm away for most of the month, so probably. So I could probably put something together for November.
Okay, so November 5th is available if you would like it. I'm doing something there, but I can move it, no problem.
Yeah, just tentatively put me down.
Okay. That would be for the rocket or for the NORAD? Okay, you're muted, so I don't know what you said.
Take your pick. I haven't done either one, so I just got to put it together.
Okay. Okay, great. Well, while we're on a roll for presentations, anybody else want to do one? Like I said, we do have November 19th and December 3rd are available for something. There's nothing scheduled in there. And then we got to start thinking about the new year. I've been talking to Michael. He's got some plans for some presentation, a whole series of presentations. So we were talking about that today, and I just said to him, well, you know what, start working on them now, but hold off until the new year, and we'll spread them out throughout in the new year. It should be pretty good. Okay. With that, anybody else have any last minute comments, questions?
Yeah, Peter, what's going on with the Pro Buildathon? Are we going to go ahead with a Buildathon, or is this
well, now that Michael's finished with the documentation and stuff, I was talking to Michael today, and I said, you know what, now let's get together for another meeting, a Jitsi session at some time soon, and then we can talk about that. Now that the documentation is done and all that stuff, right?
Because then you also have to kit it as well too. Order the parts.
Yeah, we need to talk about all that as well. Yeah, so we need to do a Jitsi session. Michael's camping, I think, next week as well, and you are. So we'll have to wait till you get back.
Okay.
Yeah.
Quick question. Brain drain, something that was been on the mind lately. I just saw the Avro Aero exhibit in Ottawa at the museum there. And I'm talking to people about the AI brain drain. And I'm just thinking the list of things invented in Ontario is huge. And they've all seen, everything gets started here and then just moves to the US. So like radio, the first radio transmission was in Ontario for Fessenden. Then the first telephone was Graham Bell. AI was invented here. Now there's a whole brain drain. It's all being moved to the US. And so on and so forth.
Oh yeah, you know what the latest one is, Hassan?
What?
The latest one is Crown Royal bottles are going down to the south.
Yeah.
Sorry, what's Crown Royal?
The whiskey.
Oh, okay. Oh,
you
okay.
belong to this group and you don't know what whiskey is? Well, okay. Okay.
Oh, Whiskey Tango Foxtrot. Yeah, of course.
Yeah.
Yes, the W's.
And that's right in Frank's backyard too. That was in Amherstburg, right?
Yeah. Speaking of Frank, you have something to say, Frank?
Yeah, and the Avro one is pretty disappointing because this great plane has been built in Ontario, and then it was shut down, and all the people also moved. All the engineers, I think, eventually all of them moved to.
They all worked on the Apollo program.
Yeah.
Right. Yeah, a couple
Frank,
of them were.
Frank had a comment?
Yeah, a couple of comments. First of all, that Crown Royal operation is just down the street from where we live. And there's 160 people from Amherstburg that work there that are going to lose their jobs. So it's very concerning for the local economy. The other one is if you're picking between the NORAD and whatever, I vote for the NORAD. I would be very interested in that. And one final thing is to comment on the arrow that a full-size replica of the arrow is now on display at Edenvale, north of Toronto, quite close to Camp Borden. And they had an open house about 2 weeks ago that brought in about 5,000 people. And they had a real good weekend. A fly-in, a drive-in, old cars, old bicycles, everything. All got together for one big day a couple of weeks ago, and it was a huge success. So I've been following the arrow for ever since it was shut down.
Frank,
Anyway,
was that arrow the one that was at Downsview?
yes, it is.
Okay.
And they've rebuilt it or reconfigured it, rejuvenated it, I guess. It's non-flying, but it is exact replica down to the inch of the original.
I saw it at Downsview when it was unveiled there, like 15 years ago or something.
Something like that, yeah. It's been hanging around different places for years, but it finally found a new home up there at the aerodrome. They had the same field that was used for pilot training in World War II.
Gotta check it out.
Yeah, it's worthwhile a trip up there.
Hmm.
They also have actual MiG fighter jet from Czechoslovakia, I think is where it came from. But it's on a pedestal there. Anyway, interesting stuff in Ontario for sure.
Yeah.
Yeah. Have you guys been to Petrolia, Oil Springs?
Yeah, I know it.
Yeah, the
And
oil
near
industry.
Sarnia.
Yeah, near Sarnia. The oil industry was born in Ontario. The first commercial oil well was here,
No,
and
so
then
it's our
before
fault.
Pennsylvania. And I mean, it's unbelievable. Like this, all this innovation happens in Ontario, and then it just gets scaled up somewhere else, and then they rewrite history to show that they are that's where it all began. But Ontario's got this kind of sort of silent spring of all these things. Let's hope the HF Renaissance begins right here at PARC.
There you go. Hey, maybe the Nano VNA grew out of our SNA. Huh.
Yeah, well,
Okay.
That's a story yet to be told, but maybe you never know.
Yeah.
Maybe it was inspired.
Who knows? Well, I was inspired enough that I went and I bought an 8302 chip, which can measure phase angles and stuff. But I never really did anything with it. And I did, several months ago, looked into it again, and I realized this is pretty complicated. I'll leave it for another year. But anyway. Okay, I guess that's it for tonight, guys. Thank you very much. It looks like everybody built the SNA except for Bob, but Bob's got a good excuse. And I guess we'll see most everybody on hopefully on the 17th. And we'll catch up with you then. 3.
Hey, Peter, can you hang around for a sec?
3.
See you guys.
All right. Have a good night, guys.
Bye.
Take care.
Thank
Bye.
you.
Cheers.
Ciao.
Good night.